Welcome to this session on network forensics. Until now, we have been seeing the technology that was used for traffic acquisition. Especially we were looking at what are all the types of devices and what is the forensic value that each of the devices provides. We were looking at security devices such as firewalls, IDS, IPS, etc. We were also looking at the routers, the switches and the application servers, authentication servers and web proxies. Now, in all of these you have to acquire the traffic. So, one of the ways we acquire traffic is through software, and the most important library that we make use of is the PCAP library. Okay, it is actually a Unix C library and it provides application programming interface for capturing and filtering the link layer frames. You also have WinPCAP, okay, and WinPCAP is used for Windows, and many of the tools such as TCPDUMP, okay, wireshark, Snort, Nmap, ngrep, etc., they actually make use of this libpcap. What it does is it takes layer 2 information and stores them for analysis. So, the libpcap actually uses Berkeley packet filter or BPF, okay, and it is actually a I should say it is a filtering language that we use. See, because you can capture all the data and then as I told you, once I capture all the packets, this use of libpcap, it actually captures all the packets that flow on your network. Now, once I capture the packet, I need to start filtering those packets, because you want to only take those that is of interest to you. You do not want, I mean, and if you look at the speed of many of these routers, it is megabytes per second or petabytes, etc. So, you can't collect almost all the data. So, you just have to collect the data and then filter those unwanted parts. How do you filter it? Now, this Berkeley packet filter actually provides a powerful filtering language, and you can use this language to filter packets and classify them as layer 2, layer 3, layer 4, or you can have a lot of combinations. I mean, it is a huge task, and in order to simplify these filtering activities, you can use a GUI, a graphical user interface software called wireshark. But then before we go into that, let us look at what you can do if you have to use only command line interfaces. Okay. So, the BPF primitives are divided into at least 3 categories. Okay. One is the type, for example, what type of host, what is the kind of network, what is the port or the port range, that is one category. Second, what is the source, the destination, whether you want to filter the packets based on the address. I mean, each one of this is a filter parameter, whether you want to filter based on the host, you want to filter based on the net, you want to filter based on the port, etc. Okay. And you can also split it based on the protocols, for example, whether you want to look at the Ethernet packets or you want to look at the IP packets, whether you want to look at IP version 6, etc. So, here is an example of a filter that we show. It says that host 192.168.0.1 and not host 10.1.1.1 and one of these ports, that is port 128 or port 139 or port 45. So, what does it mean? It tells you that you want to capture all the packets from host 192.168.0.1 and that is not related with 10.1.1.1, but the ports on which the data packet uses or on which the software uses is 138, 139 or 445. So, it will capture all these packets. You can also filter by byte value, because if you look at IP and other headers, okay, you actually have a 32 bits, and if you look at the diagram that you would be familiar with which we had seen in the previous classes, I mean each byte makes a huge difference. For example, what is this first byte to, what is the second byte to, and even within the byte the bit, each bit is important. So, Berkeley packet filter provides you to address each of these words, bytes and to a bit level. Okay. So, for example, it says TCP colon 0 colon 2 is equal to 31337, it says that the source port is 31377. Okay. So, find out what is this TCP 0 colon 2. So, it says 0 and 1. Okay. What is 0, 1 and 2? So, what does it mean? Just take a look at the TCP header, you will understand this. So, when you are reading this slide, keep next to you the TCP header, the IP header diagrams, and then see what actually it means, then you will understand what this is. For example, IP of 8 less than 64, it says match all packets where the single byte field starting at the 8th of the IP header offset is less than 64, which essentially means that TTL fields matches the Linux system. So, anyway, so IP of 9 not equal to 1, which means match frames where the single byte field at the 9th byte offset the IP header does not equal to 1. So, essentially what you should do here is you take the IP the packet, okay, the headers, and then divide it into bytes and then find out what each of those bytes mean, and then out of this what this exactly the statement. So, that is what we told you, that you should have an idea about IP headers and TCP headers etc. before you do some forensic analysis. So, you should know how to filter, what to filter. You can also filter based on the bit values. Okay. So, you can do something known as bit masking. Those who are familiar with C programming language will understand the use of the AND operator and the OR operator for bit masking. You can create complex expressions with AND and ORs, which we had seen earlier, like host 192.168.0.1 and not host 10.1.1.1 etc. The TCPDUMP is a tool which can be used to dump filter and then dump packets. Okay, it is actually a Unix tool, and in Windows it is called WinDump. Okay. So, it actually bit by bit, and it can be used with BPF to weed out those packets that are not pertinent for our investigation. So, here is an example of how to use TCPDUMP. So, if you look at this example excludes TCP port traffic 80 from the Ethernet 0 network interface using BPF. So, let us take an example of how to use TCPDUMP. Okay, the following example, that is slide that is presented, tells you how to capture data packets on ETH 0, this is the Ethernet, and what it tells is that you need to capture TCP and port 80 and not of this. So, what does it mean? I do not want TCP and packets that go to port 80, but I want other packets. Now, just to show you a demo, see here we have mentioned Ethernet 0, but I can show you that this can also be done with the wireless interface also. Here is what I have done to show you the wireless LAN interface. So, I have used just added the sudo in front of the TCPDUMP command. This is to ensure that I have the necessary permissions, the root permissions, because all these tools, most of these tools you should use as root in a Linux machine, you should have full administrative rights. So, here what we are doing is that I am just using the same command, but this time on the wireless interface. So, what I now am planning to do is that I am trying to do a ping of some website and try to see whether this command actually dumps the packets that I need. So, what I do is I will now try to dump, let us say nptel.iitm.ac.in, okay, or let us say I dump from, I ping to Google. So, what is happening here is that once I start pinging some website, say I am trying to ping Google, okay, what it does is that it actually starts capturing what are all the packets that go from my machine to Google's website. Okay. So, if you look at this, so now I will stop pinging Google. So, now you see the data capture has stopped. Again I will try to send some DNS packets. So, what I will try to do is, so I am trying to find out what is the IP address of google.com, and if I see this, okay, so I am able to send the DNS packets. So, this guy is able to capture all those DNS packets, and then it is able to get the response, then it is also capturing the NTP packets, that is network time protocol packets, etc. So, if you look at this, so other than TCP packets, it is capturing all IP packets, and other than those which I send to port 20, port 80, it captures all the packets. So, this is one way of capturing the packet, and of course, you can write it to a file. So, this TCP command has, okay, so let it be capturing the packets. So, this TCPDUMP command has a lot of other options. So, here are 5 command options. So, one of them, okay, so if you look at 1, 2, 3, fourth command, where it says -w rolling underscore spit underscore 100 MB underscore dumps dot pcap. So, essentially what it does is grabs every frame, but splits the capture into multiple files no longer than 100 MB. So, in this way you can actually capture the file, okay, and you can actually write it to a you can actually capture the packets, you can actually write it to a particular file, okay, and then you can do all sorts of filtering, etc. So, each of the command tells you what you are supposed to do. For example, if I want to listen to an ETH0 and write all the packets to a single file, then I give the command TCPDUMP -I, that is the interface, and then -w tells you what file I need to write. Then I use, say, and then similar to this, suppose I just want to grab all the packets sent to or from 10.10.10.10, then I say that TCPDUMP -I, which is the interface, then I say almost source, I say from almost all the packets whatever is goes to host 10.10.10.10, you just capture all those things and then write it into targeted underscore full packet underscore dump dot pcap, etc. So, in this way you can use TCPDUMP and capture all the packets, and remember this is a kind of live dump that we are doing right now. You can also look at TCPDUMP command line usage, okay. It might, there could be 1 or 2 minor differences depending on how it is implemented, but then in general this has options like writing into a file and then what should be the file size, etc. The next tool, if you are not very familiar with using command lines, then you could actually use the open source GUI, which is the wireshark, okay. The advantage of using wireshark is that it provides a nice GUI, but there is also a command line option available for wireshark, okay. So, what we can do is that it can actually capture the packet, it can filter the packet, then it can analyze. The advantage of using wireshark is that you will be able to group the packets together. We told you that much more easily than using any command line tools, but of course, wireshark also includes a command line called a tshark, okay, and it is similar to TCPDUMP. I mean the usage is similar to TCPDUMP, okay. So, let us take a look at the usage now. So, let us stop this for some time and then let us try to look at the usage, okay. As usual I type, and by the way, if you need to install these tools before you start using them. If you are using Lubuntu or Ubuntu, then it is sudo apt-get install and then you give the tool name, otherwise you find out the appropriate way to install, okay. So, here we can use these tools, I can type the same command line like, but in this case I am going to capture it on the wireless interface, okay. I want to write it into test.pcap and I want to capture all those files which are not for port. So, it actually warns you what you are supposed to do, okay, and then say it says the file which capture could be saved as, but could not be opened because its permission denied and so on. So, what we can do is, in that case I just don't want to write into a file, I just want to display it, okay. So, you can start capturing it, and what I can do is I can just from this again I start doing the same command. So, now if you see this, it starts capturing the packet. So, it is similar to what we had done earlier. Okay. So, what I want to tell you is the usage of all these tools are similar. Okay. So, you just have to look into the command line. So, if you want more information on these tools and the command line, just go ahead and so you can do T# minus help, or so it gives you all the command line options. It takes some time to actually get used to this command lines, but I think hope you are very familiar. In your previous courses you have done a lot of shell scripting, and if you remember, okay, all these things can be included into a shell scripts, and then the whole process can be automated. I mean, that's going to be our aim. I mean, if you want to do good forensic analysis, you can also use something called as dump cap. I mean, there are so many tools that are available. I mean, so you just have to, so dump cap also is more or less the same kind of command line. Okay, so all these use of wireshark and then T-shark actually gives you an active acquisition of data. Okay, and the problem with active acquisition of data is that it modifies the environment. Okay, and so what should I do if I do not want to modify the environment? Then you could use, actually you need to log into the machine, okay, through various kinds of interfaces. The commonly known interfaces are the console, which you can use. The other one is a secure shell. If the machine is a remote machine, you can use a secure shell. Then you can copy the files using secure copy or SFTP, or you can even telnet into a machine. You can use SNMP to monitor a machine. Okay, you can use TFTP to move the files, or there are some web and proprietary interfaces that are available to you for doing this active acquisition. So, you are all very familiar with console. Okay. So, usually you use USB kind of an adapters. I mean, people who have developed embedded systems will understand how you capture data via the serial port, which is the first communication mechanism for any embedded system. Okay. So, similarly you can actually connect to the console and then get the information. The other, as I told you, provides SSH and SCP and SFTP. It provides actually a secure way of transferring the files. Okay, the most insecure way of transferring the files or trying to find out is Telnet. Many of the hackers, okay, or attackers actually use this. If the Telnet port is open, I mean, they go ahead and use this port. Okay. So, here you could look at some examples. Okay, we have shown some examples. Probably, I mean, we can have a demo of this. So, how Telnet can be used. Okay. So, we will just go to this website. Okay. So, one of the things that it shows is that, okay, the request is timed out, and you can get information like this if you use Telnet, but the point is never try to use Telnet because it has limited amount of security. Okay. So, usually you are supposed to close the ports, Telnet ports. So, then the other place where you can try to get information is without intruding into the network is SNMP. SNMP actually collects a lot of data. You can use any of the SNMP management, network management tool, and then get the data. So, essentially what SNMP does is it polls the devices and gets the data instead of actually logging into the device. And if you look, say, SCP, SSH, Telnet, etc., you actually log into the device. Here you need not log into the device, you use a nice client which just goes into the device and gets whatever data you want to get. TFTP also tries to get log into, I mean, not log in, actually tries to get the data from the device. Okay. You can use TFTP to get transfer data from, say, firewalls and other network devices, etc. Okay. So, usually forensic investigators use files that are not supported by SCP or SFTP. Suppose you do not have support for both of them, you actually use TFTP to transfer the files. So, essentially all these are tools to transfer the files from the devices. Now, what are all the files that we are going to transfer? Actually, we use those tools like tshark and TCPDUMP to dump the packets. So, once the packets are dumped, you do not want to analyze them in the same device where you stored the packets. So, you just take those packets out, bring it to a server and then do your analysis. So, when you want to do that, you have to use these kind of devices, okay, mechanisms. For example, you can use SSH, etc. So, TFTP is one mechanism where if you do not have SSH or SFTP, you can use TFTP. Of course, the TFTP server should be running, okay, or the client should server and the client should be running, okay. In all these protocols for I mean FTP, etc., the server and the client should be there in the, usually it is there, or you can use SNMP even to transfer the data. There are also some proprietary interfaces which typically use HTTP to transfer the data, okay. So, the problem is that GUI inhibits logging into the device, etc., okay, and sometimes these proprietary interfaces you can get the screenshots, etc. So you log into the device, you might have to log into the device and then the web server should be running. Suppose someone closes the web server, you can't access it, etc. And one of the things you should be careful is that if the server closes down, you should always be monitoring for all these processes to be up in all these devices. Can we do inspection without access? Yes, we can. Okay, we can do something known as port scanning. I think you should be very familiar with this. Vasan would have talked about this port scanning. Then you can also look at vulnerability scans and other things like penetration testing, etc., which can, but some of these vulnerability scanning can crash a device, okay. But these things you can do inspection without access. For example, SSH and all, you need to access to the other side. Here you do not access to the other side, you just send the data and get those values, okay. So, what should be your strategy as a network forensic specialist, okay? First, refrain from rebooting or powering devices down, because once you do that, you lose the data, especially the volatile data. For example, the ARP tables, the current state of the devices, all these things go off, okay. In some devices, if you reboot, the log files goes off. One of the examples is the temp in the Linux machines. The /tmp directory actually is cleaned up during every boot, and it is only a scratchpad kind of directory. So, similarly, all these devices use some kind of scratchpad locations, and these are all the locations that might go off if you switch off and switch on the device. Therefore, you have to collect these scratchpad memories or scratchpad locations and then try to do the analysis, okay. If the network is remote, then you have no other option but to connect via console or SSH, etc. Okay. One of the things you should look at is record the system time. See, these devices could be at different time zones. One, they may not be sync in time, okay, unless they use something like NTP, network time protocol, and then sync their timings. So, you should also look at the time skew, okay. So, you cannot have some event that happened before and some event that happened after, because if you do that, then the correlation becomes extremely difficult, okay. And you should be able to collect evidence according to the volatility, okay. Okay. So, one of the things is when all else is equal, go with the data that is most likely to change or be lost, okay. That should be collected as early as possible, okay. And the most important of all the activities that you should do is that you could document all the activities, okay. Record the commands, okay. There are a lot of tools that you can use to record the commands, okay. For example, one of the tools that you could use is history. So, if you look at this, I type history, I will be able to see what are all the commands that I typed before, okay. So, these kind of tools are and could be very important. One more thing with this history, sometimes it only stores, it actually rolls back. So, it may not be able to store everything. So, you need to be very careful, and these kind of volatile data you should be able to take out very easily, and the rest of the data I think you can collect at your own leisure, but that does not mean that you collect it very late, because an attacker, if he gets access to these kind of data, he can even modify those data. Okay, a good reference for this is the Davidoff and Ham book, which we recommend for you to read, okay. So, it covers 2 chapters, whatever we have discussed covers 2 chapters, and in the next session we will take a look at wireshark just to see how to apply packet filtering, etc. Thank you very much.